Solve exponential equations without logarithms. Now, the only way to really do this is if both sides of an exponential equation have the same base, then the exponents must be equal. Meaning, if we would have 3 to the x equals 3 to the fourth, you can see that the base of both of these exponential equations, the base is 3. Therefore, the exponents must be equal. So x equals 4. Okay, let's solve some equations. So we have 9 raised to the 2x plus 3 equals 27 to the x minus 7. And you're thinking, well, those bases are not the same. No, they're not. 9 and 27 are not the same. But I can change these bases so that they are the same. Because think about 9. What do you know about 9? Well, 9 is the same as 3 squared. So I have 3 squared, and I'm still multiplying then by the exponent of 2x plus 3. That's going to equal, well, what do I know about 27? Well, 27 is 3 to the third power. And I'm still going to multiply that then by the exponent of x minus 7. So now we have two exponentials with a base of 3. So you have to understand and remember your perfect squares and your cubes and all of those things so that you can find bases to be the same. Now I can set my exponents equal. So 2 times the quantity 2x plus 3 equals 3 times the quantity x minus 7. To solve this, our first step is to distribute on both sides. So when I distribute the 2 on the left, I've got 4x plus 6, because 2 times 2x is 4x and 2 times 3 is 6, equals 3 times x is 3x, and 3 times negative 7 is negative 21. So now I'm ready to solve. I need to get all the x's on one side, all of the numbers, the constants on the right. So first, I'm going to subtract 3x from both sides. 4x minus 3x is 1x. I still have plus 6 equals negative 21. Last step, let's subtract 6 from both sides, and that leaves me with x equals a negative 27. And that is the first one. We're going to do a couple more. Stick with me as long as you'd like. Here we have a fraction. So 4 to the 3x equals 1/16. In a fraction, if this throws you off, then just have a little moment and say, what do I know? Well, I know that 4 to the first is 4. 4 squared is 16. Well, 16 and 1/16 are not the same. But remember the definition of negative exponents. So 4 to the negative first is 1/4, and 4 to the negative second is 1/16. Therefore, I can rewrite the right side of my equation, right? I've got 4 to the 3x equals 1/16. So I can leave 4 to the 3x as is, keep the base of 4, and I can rewrite 1/16 as 4 to the negative second. Now my bases are the same. I can set my exponents equal. So 3x equals negative 2. To solve that, I just divide both sides by 3 to isolate x, and x is a negative 2/3. 8 to the x plus 3 equals 16 to the x minus 4. What base? Well, when you're looking at 8, nothing squared equals 8. So then you got to think, well, is anything cubed? Well, 2 cubed equals 8, and 2 to the fourth equals 16. So the same base is going to be 2. So I use 2 to the third, multiplied by the exponent of x plus 3, equals 2 to the fourth, multiplied by the exponent of x minus 4. Since the bases are the same, let's set the exponents equal. 3 times the quantity x plus 3 equals 4 times the quantity x minus 4. Let's distribute on both sides, which leads us to 3x plus 9 equals 4x minus 16. I like my x's to be positive, so I'm going to subtract 3x from both sides. That gives me 9 equals x minus 16, and the last step, add 16 to both sides. We end up with x equals a positive 25. And let's just do one more. You'll notice here the 1/36th. That's the same as 6 to the negative second. If you can recognize that 6 squared is 36, that means 6 to the negative second is 1/36 by definition of negative exponents. So let's go ahead and rewrite this. I keep my 6 to the negative 2x plus 3 on the left, and my 1/36 on the right, I replace with 6 to the negative second. Now I have bases of 6 on both sides, so I set my exponents equal. Negative 2x plus 3 equals negative 2. I want to solve. I already have all my x's isolated on the left, so I subtract 3, and I have negative 2x equals negative 5. Divide both sides by a negative 2 to isolate x, and 2 negatives gives me a positive. So I end up with x equaling a positive 5/2.